Let's go to page 135 and let's do section 11.6. These are similar triangles. When you have two triangles, if they are similar, it means they have the same shapes. It means they have the same shape but different sizes. So one would be bigger than the other. If they have the same size and then they are same shape, then it means they're congruent. Okay, so over here you have the triangle ABC and you have the triangle DEF. And normally you designate the small letter to facing the angle, so you're going to have the side small b facing the big angle A. So this would be A, and this would be B and C. So B facing B, A facing A, C facing C. So this would be DEF. Once you have a similar triangle, then you can write your ratio. And as long as you match things correspondingly, then you can write your equation in any way. So you can have the C over F. So this side over this will equal to this over that, so it would be like A over D. Okay. And you can also write the sum. For example, you can have the A plus C. You can have A plus C over B. So this will equal to D plus F over E. As long as you match the A with the D, C with the F, and B with the E. So you can write your ratio. You can write your equation of proportions in any way, okay, as long as you match things up correspondingly. Okay, now there are different ways of proving that two triangles are similar. So on page 135, the first one is the AA. So A stands for angle. So if two of the angles are congruent, so this is congruent to this. So if A is congruent to D and B is congruent to E, okay, so that means the third angle will be also congruent, and therefore that two triangles would be similar. Okay, so and on page 136, the second one is the SAS. So what it's saying is that now for SAS, for similar triangles, these are correct. They will have the same ratio. Okay, so let's say if the side C is equal to twice the length of F, and A is twice the length of D, and angle B is congruent to angle E. So that would be SAS. Okay, so again, the side would be in the same ratio. Now, if C is twice as long as F, but A is 3 times D, then they are not similar. Okay, so this won't be similar. Now let's go to page 136, number 3. You have the SSS. So that means if all three corresponding sides, if they have all same ratio, then there would be similar triangle. Okay, again, for example, if C is twice F, and B equal to 2 times E, A equal to 2 times D, then it would be SSS, similar triangles. Okay, so let's go to some examples. On page 136, let's do example 11-11. Okay, so you have triangle A, B, C, and then you have the D and E. And it's giving that AB equal to 3AD. So AB equal to 3 times. So what we can do is just go and call that. Normally you can call it just. Usually give it X, but usually you want to reserve the X for what you're looking for. So I'm going to call this X, and you can call this like maybe like D, and this would be 3D. Okay, or you can call it N. So just designate a letter. So you can see that the big triangle is 3 times the small triangle. Okay, so therefore this would be 3 times SS, so X will equal to 3 times 6, so X will equal to 18. Okay, so you can just look at the ratio. So big triangle is 3 times the small triangle, so X would be 3 times the DE, so just times by, so 3 times 6 give you 18. Okay, let's go to example 11-12. So you have a right triangle. Now when you have a triangle, it's it's best to draw your 30-60 triangle. That way it's easier to tell which leg is long leg, which is short leg. Okay, so you have a triangle ABC, and angle C is the right angle, and you have the altitude. So again, when you have a 30-60 spatial triangle, when you draw the altitude, it's still easy to see which is long, which is short. Okay. So if your triangle is kind of bad, it's kind of sometimes it's hard to tell which is the long leg, which is the short leg, and it's easy to write the equation wrong. Okay, so the altitude is what you're looking for, and it's divided segment into 4 and 8. Okay. Now, when you start out with a right triangle, if you draw any perpendicular line to a side or parallel line to a side, then all the triangle will be similar. So in this case, right now you have 3 triangles. You have the small triangle, you have the medium triangle, and you have the large triangle. So I'm going to use the small triangle and the medium triangle. I'm going to use the short leg over long leg. Okay, so it'll be 4 over x. So short over long will equal to the short over long. Okay. And after that, you can just go and solve. So cross multiply. And then x will equal to square root of 32. So x will equal to 4 square root of 2. Okay, let's go to next example. Example 11-13. Okay, so you have a triangle over here. A, B, C, and you have the angle bisector of the angle A. And so in this case, I'm just going to call this A, B, C, D. Okay, so from here, your ratio would be, you just go and put whatever you see, you just put as your ratio. So just that's your fraction and that's your equal. Okay. So the relationship between these four lengths would be A over B equal to C over D. So A over B equal to C over D. So angle bisector theorem is kind of fairly easy to remember this way. Okay, let's go to example 11-14. You got A, B, C, and you have the angle bisector. Okay, so you want to prove that AI over IX equal to AX over IX. So if you just look at this way, it's kind of hard to see. So what you want to do is you need to draw the last angle bisector. You need to draw this one also. And one thing to remember is that all 3 angle bisector will meet in one point. And the I stand for in center, so we learned this from before. So now what you want to do is you want to just look at this triangle right over here. Okay, so if you just look at this triangle, and then you apply the angle bisector theorem. So you're gonna have AC over AI equal to CX over IX. Right? So you get an angle bisector for this pink triangle. So this over this equal to this over that. Then after that, you go ahead and first let's go and cross multiply. So you got AI times CX equal to AC times IX. And then after that, since I need to keep the AI, so I need to divide by CX. So that this will cancel out. And I need to keep the AC, so I need to divide by IX. So that it will cancel out. And so I have a AI over IX equal to AC over CX. Okay, and that's it. Okay, let's go to example 11-15. Okay, so you have a big triangle over here. And so you got A, B, C. Now, don't assume that this is the right angle. It doesn't say so, so it's not. Okay. And so this is the D, this is the E, and so this is given as a right angle. Okay, so let's get all the information in. Okay, so AD equal to 5, so I'm going to put a number inside. So normally if it's entire length, I put on the outside. Okay, so DB equal to 5, so this is 5, this is 5, so I put 10 out here, so this means this whole length. Okay, and then next you got EC equal to 8. So EC equal to 8, so that's kind of right over here. EC equal to 8, and 2AE equal to 8, so this would be a 4. Okay, so that means this is 12 out here. And its angle AED is a right angle, and you're looking for BC. Okay. Now, right now, there's no similarity, so the triangles are not similar. So what you want to do is, you want to go ahead and draw a parallel line to that. So you draw the parallel line right over here. Now notice this is 5, 5, right? So these two are equal. So when you draw a parallel line, this would be similar triangles. So these two would be also the same. So this would be a 4, and this would be a 4. Okay. And if you notice that the big triangle is twice the small triangle, okay. And also, since this is right angle, you can use Pythagorean Theorem, so this would be a 3, right? 3, 4, 5 triangle. And again, the big triangle is twice a small triangle, so this would be twice as high, so this would be a 6. So now we can use the Pythagorean Theorem for the x. Okay. So x will equal to square root of 6 squared plus 4 squared. So x will equal to square root of 36 plus 16. So x equal to square root of 52. So x will equal to 2 square root of 13. Okay, so next thing that I want to cover would be the picture in the exercise 11-18. Now, the exercise 11-18, you have a trapezoid. And you have the median, so you got T, TC, so with a trapezoid and a median, okay, there are certain interesting relationships. So the RE is, this one is equal to average of the two, so equal to TZ plus AP over 2. So TZ plus AP over 2 give you the RE. Now also ID will equal to the difference, so half of the difference. So TZ minus AP, so you got AP minus TZ over 2. Okay, I'm going to switch this so it's easier to kind of to remember. So you got AP plus TZ. Okay, so you can AP plus TZ divided by 2. So when you add, divide by 2, you get a long median. When you subtract, divide by 2, you get this ID right over here. Okay, so again, you add, divide by 2, you get this. You subtract, divide by 2, you get that. Okay, and also all these would be similar triangles because all these are parallel lines. Okay, so these are similar triangles. You got small triangle, you got medium triangle, you got a big triangle. So all these are similar triangles, and you can use a ratio. But make sure you match the side carefully. So like this side match with this side, this match with this side. Okay, because they're kind of flipped over. So just be aware of that. Okay. So you can use this to solve many of the trapezoid problem. Okay. Now for exercise 11-19, this kind of problem also shows up very often in the computation. Normally it comes in the form of 2 poles and have crossing wire on the 2 poles. So normally you have the pole here, and then you have the wire going to opposite corner. And then you have this height over here, and normally they have the A and the B. So normally they want you to find the H. Okay, so the easy way to remember this is that you got 1 over A plus 1 over B equal to 1 over H. Okay, so this is a very important trick to remember. Okay. And this also came from the trapezoid problem, that if you draw this line over here, see, so that is your trapezoid right over here. Okay. So those are important things to remember and to know, and it will help you to solve a lot of problems and make it a lot easier.